In this session, we are going to see the three fundamental themes behind the smart mathematics. There are many techniques that you're going to learn, but smart math really is based on three fundamentals that you see on your screen. The first one is looking at an arithmetic problem from left to right. The traditional way is to solve the problem from right to left. What we are proposing is to go from left to right? So that's a fundamental shift. The second one is whenever you look at numbers, look at from the perspective of base numbers, right? Is it closer to 10? Is it closer to 100? Is it closer to 1000? Not all numbers may be closer to these bases, right? But still, go ahead and look for it. If you have a number closer to 10, 100, 1000, it's not only easier to handle, we have many techniques that can use these numbers, right? And you will be able to do the computations faster. The third one is simplification. Whenever you look at an arithmetic problem, try to simplify so that you can do things faster, right? It can be rearranging the numbers. It can be looking at the numbers from a different perspective. So this process of simplification is very, very essential. We will be going over these fundamentals throughout this program as we explain different techniques, right? So these are very, very fundamental. You must understand this so that you derive full value out of this smart math approach. So let's see what is this from left to right. I told you the traditional way, the number that you see, right? We are trying to add 43 and 22. The traditional way is you go from right to left. You first add these two numbers, 3 plus 2 is 5, then you add 4 plus 2, right? You first add this, then you add this. But in smart mathematics, you go from left to right. You first add 4 plus 2, right? And note it as 6, and then you add 3 plus 2, note it as 5, so you have 65. If you really see, this is not only faster, but really helpful. But I just want to pause for a moment and ask, why do you think this will be effective? Just think, why do you think this will be faster and effective? That is, the left to right method will be better than the right to left method. Think. Yes, the left to right method is aligned to the way we write. How do we write? We go from left to right, right? When you write a sentence, you start from the left. If you're using a notebook or even a computer screen, you start here, right? The leftmost part of the screen or the leftmost part of the book. And then you go about it and then go to right. So our mind is really attuned to this left to right approach, which is why by using this approach, right, you are tapping into our natural way of processing, and which is why this technique is able to solve problems faster and effectively, right? So let's see one more example. 42 plus 29, right? So what do? I don't go from right to left. I go from left to right? So I don't add 2 plus 9 to start with. Instead, I add 4 plus 2. 4 plus 2 is 6. We have noted it. Then comes 2 plus 9, that is 11. I mark it in a different color, right? You can put a circle or whatever, because this number need to be carried over, right? So I need to add 1 to this 6, so it becomes 7. So the answer is 71, right? If you don't have a colored pen or pencil, you can circle it, right? So that it stands out. So you know this 1 needs to be added to 6, right? Isn't this simple? Let's do more computation, so you really understand what we are talking about. Right? So let's see one more example. 56 minus 29. You start with what? 5 and 2, right? The difference between 5 and 2 is 3. I put it here. 6 minus 9, right? I need to borrow, right? I need to borrow. 1 6 minus 9 is 17, right? So I have borrowed. How do I indicate? So which means that I need to subtract this 1 from this. So I put it in a different color, and then I indicate this using a bar. You can indicate it using a bar, or put a cross mark, or whatever is convenient to you, because you are just telling yourself you have borrowed, and hence you need to subtract. You should not add, right? So you have what? So I subtract whatever I borrowed, right? So 3 minus 1 becomes 2, and 7 is there, so you have 27 as the answer, right? Let's see a multiplication 1, right? So 148 by 2, right? I'm not going from 8 into 2, then 2 into 4, then 2 into 1. I start with here, right? Remember, left to right. 2 into 1 is 2, then 2 into 4 is 8, and then 2 into 8 is 16. So I have 2 digits here, which means what? I need to add this. I'm representing in a different color. You can circle it, right? So that it's clear in your mind. So this needs to be added to 8. So 8 becomes 9. We have the answer 296. Isn't this easy? Right? So that's the whole thing of looking at an arithmetic problem from left to right. We don't go from right to left. Right? I'm not saying right to left is wrong. Okay, that's something that's the conventional, traditional route. But left to right is faster and more effective. Okay. The other concept, the fundamental concept, is looking at a number from a base number. Okay. The complementary method is what we are going to use here. Okay. Let's look at examples. When you see a number 8 and 9, think of 8 and 9 as complements of 10, right? That is represented as minus 2 and minus 1. It is basically 8 is short of 2 to 10, right? 9 is short of 1 to 10. So similarly, when I see the number 91 and 94, look at these numbers as complements of 100, right? It is 91 is less than 100 by 9, right? So because it is less, I am representing it as minus 9 here. Look at the number 1002, right? When you see this as complement of 1000, it is excess of 1000. So I put it as plus, right? Why am I doing this? Because there are many techniques which use the complementary method. Okay, suppose if you have to multiply 1002 into 1004, right? You don't have to take minutes. By using complementary method, you can do the computation in a matter of seconds. Yes, matter of seconds. But you should learn to look at these numbers as complements of 10, 100, or 1000, right? Because this will really help you. You need to start viewing numbers like this, right? One is left to right, the other one is complementary method, right? It may be difficult to start with, but we are going to give you a lot of practice problems, so you can really master this, right? So let's see the third one, which is the process of simplification. If I show these arithmetic problems, okay, don't jump into solving them, right? Of course, solving is the objective, but I want you to think in what ways can I simplify these arithmetic problems. The objective is simplification, so that you can do these computations in your mind, okay? In your mind first. because the objective is, can I do these computations in a fast manner, okay, in our mind, right? I don't want to be using pen and paper, right? You may be using pen and paper to start with, but over time, we want you to reach a state that you can do these computations in your mind, right? So if you want, pause for a moment so that you can identify ways and means to simplify this. How can I represent this in a simpler manner? Yes, the objective is to compute 44 into 25, 12 into 50, right? But can I write this in a different manner so that the computation is faster for me? 44 into 25 can be written as 11 into 4 into 25. 12 into 50 can be written as 6 into 2 into 50. 93 into 67 can be written as 31 into 3 into 67. If you see, in all this, I am highlighting these in a different color. Why? Because 4 into 25 is 100. It becomes easier, right? 1100. 2 into 50 is 100. This is 600. What is 3 into 67? 201. 201 into 31 is easier, right? And 49 into 51, I can write it as 50 minus 1 into 50 plus 1. This is also easier to manage, right? So we want you to look at things to simplify computation, right? So as I said, we'll be revisiting these three fundamentals, okay, while discussing many techniques, right? So as I said, these three techniques are very fundamental, very core to how we solve problems the smart mathematics way, right? Remember, our objective is to do things faster, more accuracy, and in our minds. So doing things from left to right instead of right to left, viewing numbers as complements of some base numbers like 100, 200, 100, 1000, 10,000s, right? Complements of base numbers. And third, trying to simplify the computation in a manner, right? The computation itself becomes easier and faster, right? So these are the three techniques, or rather three fundamental themes that I wanted to cover as we start off this program. Okay,